So so thank you for the introduction. My name is Chris Bergh. I have a long background in building software systems and building data science and data and analytics systems. And so today's topic is, it really is about the system. And so what we're going to talk to today is how to power AI with data ops. And the theme is really no model is an island. And so in the activity of building a model, in fact, the activity of doing anything in data and analytics, our customers are really expecting original insight, delivered fast, having low errors, and increasingly with low cost. And those really, in some ways, conflicting demands are hard to do. And so that's what really the topic's going to talk about today. And so I'm going to start off today with almost a philosophical discussion and then go into no model is an island and talk through some examples and then talk through a scenario and give a conclusion. And so the philosophy is going to start with this really strange idea in a technical presentation to say what you do is much less important than how you do it. And so why would I bring that up? Well, here's a perspective. And so when I started managing people who did data science and data and analytics and data visualization back in 2005 after a career as a software engineer and a software engineering manager, but there was a lot of problems. And my first instinct was to blame the person who was doing the work and saying they screwed up, it's their fault. And I realized that that wasn't the case. In fact, if you read Dr. Deming, who was kind of one of the originators of the lean movement or the Toyota production system, 94% of problems are from the system and not the person. And so what are the characteristics of a system that makes a team that does data analytics, data science, data visualization work together? And so there's another person who you may have heard of, Elon Musk, who talks about in building Tesla, the factory, the machine that makes the machine being very important. And that's another metaphor about what you do is much less important than how you do it. And so I've got this long career and started my career at NASA working on AI algorithms for air traffic control. And they're really interesting, and there's a lot of cool stuff happening with models and algorithms, a lot of cool stuff happening with pipelines and visualization and even the data itself. And these are all really interesting topics. My perspective is that actually the processes that act on it, how you do it, how you develop those things, how you deploy those things, how you monitor those things, how you iterate and improve those things, how you collaborate in the creation of those things, and how you measure the processes that act on those is all much more important than the work that you do, because we live in a world of change. And so how do you make those, how do you build a system that allows you to iterate and improve upon all those what you do pieces? And so this is a very contrarian perspective that the process, the people, the operations is much more important than the particular tool or technology and data. And again, I don't want to diss the cool tools. They're all really good. I just think that this right-hand side is a lot more value. And so what does that mean? Well, I think it starts with a change in focus or mindset. And I think what that means, I'm gonna stop my webcam here, is about focusing on the cycle time at which you do work, how fast you can get something in your mind, get it to your keyboard, and then get it into a system where it ends up in the eyes of your prospective customer, and then do that over again and over again. And so the cycle time of innovation and continuous delivery. And then the second part is how much can you create things, models, data sets, visualizations that people trust, that they believe in, that they want to follow. And to do that, you've got to think about what you do as a factory and think about error rates. How many defects are you creating? And do your customers trust what they're getting? And then, data and analytics is a team sport. And how do you collaborate both inter and intra-team and do that in a way that doesn't have a lot of bureaucracy and meetings? And then finally, how do you get analytic about the processes that you use to build analytics? How do you measure your productivity? And so in a lot of ways, most companies currently don't do very well at this. They're typically have many more predictive models in development than are in production. The time at which they can change things like data warehouses or data lakes is incredibly slow, measured in weeks or months. A lot of customers that I talk to are happy if they get through a month without a major error. And there's a lot of Hatfields and McCoys. The data scientists think the IT team is stupid. The IT team thinks the self-service team's out of control. And surprisingly, for data and analytics functions, no one can measure very much about how their team's working, how fast they're working, how many errors they have. There's not a lot of measurement of the process to create analytics. And we've done surveys and backed this up. And as a result, all these things mean that the costs to do data and analytics are actually high because of a lot of extra work that's done. And the number of unhappy customers is actually high. And you can see that from surveys and lack of data trust, dissatisfaction in analytics, just the number of data science and analytic consulting companies who say, give us some data and we'll do what your internal team can't. And as a result, and this reflects my experience, data and analytic teams are suffering. It's hard to be in a data and analytic team when your customers think you're going too slow, when your customers don't trust the data, when internally your team is stymied at trying new things. And so this was my experience for 7 or 8 years before I founded the company, was just being unhappy with not being able to have success at all these different things. And so when we started the company, we kind of had looked at the success that software had, the success that manufacturing had, and kind of improving the processes in which they work. And so software calls that DevOps or Agile. In manufacturing, there's the concept of lean. And I think a lot of those ideas need to apply to the world of data science and analytics. And so we call that DataOps. And it's really a set of technical practices and cultural norms and architecture patterns that really enable the rapid cycle of delivering insight created by anything, a model, a visualization, a data transformation, accessing data, and doing that in a way that produces things that are not that produces correct things, that has low errors. And that could be data quality, it could be timeliness, and then collaboration across this complicated landscape of people and tools, and then clear measurement of the results. And so that's the concept that we're going to talk to today about DataOps. And so since most people here are interested in data science, how does this apply, these DataOps idea apply to a model? And so the next part of my presentation is really to talk about no model as an island. And so in that, another aphorism that we talk about in the world of DataOps is it's not about DataOps. It's not about data silos. It's about people and tool silos. So let's just start with the world the way it is. And most people have these roles or some intersection of these roles, but there are people who work with data. Sometimes they're called data engineers or ETL engineers, data management. There are people who work with algorithms, data scientists, people who do AI. There are people who work visualizing data, or they work embedded in a line of business to do self-service. There are people who do data governance, who are concerned with risk and understanding. And then finally, there's people who run production operations. And all these people are involved in kind of the work in data and analytics. And yeah, you could draw different circles on them depending if they're a big company or small company, and maybe they have different names. But in general, these are the functional areas. And so the data and analytics market itself is $100 billion in software, thousands of companies, all of which do different varieties of data visualization or self-service analytics, self-service BI, AutoML, data science tools, data catalog tools, data transformation tools, databases, cloud providers. There's just an enormous variety of tools out there. And, people love their tools. And so, some of those tools are more code-based, where you write SQL or write Python, or you write IPython or DSL. Some are more visual-based, where you've got a nice flowchart UI or just a nice drag-and-drop UI. But inevitably we work in teams. So let's just go through a simple example. So I'm a data engineer and I source some data. It's 2 people and their sales amount. Now I'm a data scientist. I take that work from the data engineer and I apply a clustering algorithm to it. And these 2 people end up in a segment of high value and low value. Fantastic. Now the self-service BI team does it. They build a visualization, but they kind of know something that these other teams don't. They've got their own small file that says who's the owner of these accounts. And they mix in that data into their report, and then they visualize it. And then finally, the poor data governance people's got to say, well, the name, this column came from the raw data. and the sales part came from the raw data, but the segment came from the data science team, and they've got to create what's called the data dictionary, and for people to understand where it came from. And then finally, the production people take all that stuff and run it in production and make sure that it's still working. And so what's interesting is in a lot of organizations, there's kind of separate development processes teams. The data engineering team has their own process. Sometimes it's more akin to a traditional waterfall software development process. Data science teams tend to be quicker, but tend to be more heroic. Self-service teams sometimes just do things and push it to get it into production with a push of a button. Data governance teams have their own process, and finally production operations. And so these teams have their, how they work, the processes at which they sort of create and deploy and develop are different, but they're all have to work together. And in fact, doing data science has its own set of unique challenges, right? Because in some ways, you're using data to find a set of code. You're prepping data, building features, building the model, evaluating or training it, and then iterating upon it. And so the development process of a predictive model is different than that of a, for instance, a bunch of SQL code or a visualization. And it has its own unique challenges. And of course, the famous Google paper talked about, the code that you create to ML, the model and its parameters itself, is actually a very small part of the whole system that it has to work in. And so let's go through another case and talk about this. So in order to develop analytics, everyone gets data from a lot of places, right? ERP, CRM, internal data, open data, APIs, files. But we all kind of work in a factory. And what do I mean by that is that if you think about how those teams work together, they get data and put it in a database, and there's 50 different databases that you may want to use. And there's tools to transform data, ETL, ELT, MapReduce jobs, Spark jobs, doing data frames. There's tools like Informatica and Talend and Airflow. And then there's a lot of tools to do data science, from AutoML tools to writing Jupyter notebooks to a whole bunch of tools that help a whole data science team work together. And then there's data viz tools like Tableau and Cognos and a ton of them. And then there's data catalog tools. And all of these pieces in some ways are part of the journey out front that data goes to value to the customer. And so I guess we take it as a given that in this, that there is no Uber tool that does everything, that every company that we work with has got, in some cases, a couple versions of those tools. And so there's a part in software engineering called Conway's Law. It means that the technical artifacts that we create sometimes reflect the organizational structure that we're building in. And it's actually not meant to be a compliment. And so in a lot of organizations, the IT team tends to be a little more on the data science data side. The data science team tends to be more on the algorithm side. The line of business teams tends to be involved in self-service. Sometimes they're all work for the same boss. Sometimes they all work for different bosses. But they kind of think of them as owning pieces of this big system. And the challenge when you have this complicated organizational model put into a pipeline is what happens when something goes wrong? How do you find and fix it? How do you actually develop new things? How do you get end-to-end visibility of all this? And so these teams also have to iteratively work or desire to iteratively work. They've got to have what we call an innovation pipeline, take ideas, get it in development, push it to production across a diverse set of technical environments, development, production, with diverse sets of teams and a diverse set of tools. And so we kind of think of that as like, if you look at it from an architecture perspective and think of it, I've got a production environment, and maybe that means a VPC in Amazon, or it maybe means a set of servers. And in that production environment, we think that you should run that production like a factory, like an assembly line, and monitor it for errors so that you have a very high quality Toyota product at the end. And that you should be able to deploy across those environments. Maybe you have a dev and test environment, maybe you don't. Maybe you just have a dev environment, then you go to production, maybe you've got 5 levels, maybe you got 3. But also you need, in order to do that deployment, you need to be able to abstract the environments that you work in, the tools and tool chains. And so continuous deployment into production, I think, is also a really interesting aspect that we need to do. And so both these things have to happen at the same time. And here's where the challenge that most people, and in some cases a disbelief that you can actually do these things without a huge amount of heroism. So can you run a factory that produces very low errors, inaccurate model predictions, poor data quality, late code errors in production? Can you deploy continuously in minutes or hours or days something new, a new model, an update to a model, a new data set? And can you do that across a set of teams that, of course, now no one works in an office, but where they don't sit at the same table, or they don't even work for the same boss, or even in the same country in the same time zone? And then, since we all believe in being a data-driven organization, can you have a system that throws off enough data that you can actually measure these things to show that all these processes are understood and moving? And so that's the perspective, that no model's an island, is part of a system. The characteristics of the system are that I talked about. And so I think this is, in my experience, the last sort of 15 years I've delved in data and analytics, and the hundreds of companies I've interacted with, I think this is a true representation of the way larger enterprises work. Well, of course, there's differences, but I think in general it's right. And so when we come to companies and they say, wow, that sounds great, Chris. This idea of data ops, or we'd like to work more iteratively. We'd like to not have challenges between our data scientist team and our IT team. We'd like to be able to have more customer data trust. How do we do it? Where do we start? Sounds good, but how do we do this transformation? And so, I think, as I said, it's not about, a lot of people feel burdened by, God, I got to get the next analysis out. I got to tweak the model. I got to get the new model, the new data set. And that's all they focus on. And so it is about this perspective of building a system that makes it easier to answer the next question instead of just answering the next question. And so when people come to us, we start to say, well, let's decompose the benefits of data ops. Can you work in a way, can you find a problem where moving a model into production is incredibly slow? Or you've got a system that's running and it has so many problems and errors and no one's trusting the data. Or you've got a data science team and an IT team who are not talking to each other. And how would that work? So let me go through some examples. The first idea is to apply a theory, the theory of constraints. And that is that if you think of your system as a set of interlocking processes, find where the bottlenecks are in the processes, where the constraints are, and fix those first, because that's where the most benefit will accrue. And there are books that talk about this, from manufacturing to software. And so let me start off with an example. So here's a European telecom. They had a data warehouse and its associated data transformations and models and visualizations. And making a change, it took 4 months to go through these 4 environments. A dev environment, a test environment, a production. That's just too slow for the speed of business. And so a question would be asked, and then 4 months later, you could actually see the result. That's just too slow. And one of the reasons it's too slow is because they had 4 environments, and moving things from one environment to the other was incredibly unautomated. And there was no sort of abstraction of what the environment was, no way to automatically or move things from one place to the other. And partly the reason is that there was a sense of distrust that, how do I move things from a development environment to the test environment? And to do that, to make sure that it works, well, you need to run a whole bunch of automated tests on top of all the work that you do to make sure that it's right. And they had a couple of unit tests in development, but that's not enough. You need to have a whole set of system tests, regression tests, functional tests, testing whether your model is being predictive, testing whether the code, the data is going into it is right, testing it whether the outcome is actually being fit into whatever system it goes to. And so these tests actually are reminiscent in a development environment a lot like a functional test or regression test. And by running these tests from end to end in every environment, parameterized based on different sets of test data, you can then prove that the system works. And you get a lot of trust then that moving it from one environment to the other. And instead of replacing technology review boards and the ideas in people's heads, you build a system that has abstracts environments, that has automated tests across it, across all these tools to make it work. So that's one idea. Think of a deployment problem. It takes months to deploy. Here's another example of a transportation company, and they had something in production. And yeah, it was a challenge to deploy, but there was a lack of customer data trust, and they just were getting they were putting information in front of their business customers that was wrong, and they didn't know it, and the business customers were finding it first. And that led to lack of trust and sort of, sort of sneers at the data science and engineering team. And they had this incredibly interesting environment, right? Because they had vehicles that, basically could throw off streaming data. And then they had internal systems that are more batch or fast batch. And so they had these, think of them as sensors, NiFi, Enterprise Service Bus, Kafka, Batch Informatica, predictive models that are all running on top of this stream of data. And then taking some of the results and putting in a big old Oracle database. And then Jupyter Notebooks and Talend running, and then all the users on top of it. And they also were moving to S3 and Redshift and Amazon. And each one of these pieces was kind of owned by different groups in the organization. And what was happening is the business customers were finding that this wasn't right. And then they'd have to sort of dig in where the business customer would say, this looks weird. And is it the Tableau notebook? Or is it the IPython notebook? Is it in Oracle? Did it come from NiFi or Kafka? And so if it turns out that like the one set of vehicles is giving erroneous data, you could spend half a day's work diagnosing the problem with 4 or 5 people, in fact, some of your best people, just to know where it is, let alone fix it. And so that just it's not fun work to have that happen, and it's actually not valuable work, and it's expensive work. And so a way to solve that is to say, okay, you have a running system. Let's put something on top of it that monitors in flight what's happening with the data and the artifacts from data, and then tests and monitors to see if they're right. So is this class of vehicle actually producing data at the same rate it did last week? Does the data look the same size and shape, or have the same relative number of sum of key values? Is there a statistical difference between those two? And as you go through each one of these systems and tools, you can build a set of monitors that can actually start to throw off alerts saying, this vehicle is no longer in compliance. It gave a sum of 1 million, data points last week. This week it's giving 300,000. Something's weird. Maybe you should go look at that. And maybe you should go look at that before your customers do. And perhaps that's an email or a Jira ticket or a Slack message, but some way that as a team, something's up before your customers do. And maybe it's fine, maybe it's not. Maybe it's something that you can fix and patch before your customer sees it, or maybe it's just something that you release note. But you're ahead of the game. And instead of having your whole team chase something, you've known where the problem is, and you're seen as more valuable, and it increases both your team's perception with the customer as well as their trust of the data. And so here's another case, and this is another way that people approach data ops. And we talked about this view that data and analytics in bigger companies is not done in one team. It's done in lots of different places. And some organizations have a central team who gives access to lots of diverse teams across the company. And they tend to be in what's called lines of business. And so in a top 5 bank, well, most banks have commercial banks and retail banks. They have brokerages. They have wealth planning units, and they've got a lot of different businesses that they're trying to cross-sell and upsell to, and be able to maximize the customer's experience in return. And so when people start to get data itself to work with customers, how do you make sure that they're using that data in the right way? How do you make sure they're compliant with what you want them to do, and not exporting it, not integrating in a way that causes a problem? And so can you give them a set of data and a set of tools to act on that data in a little basket, and then that in a little sandbox, and then have a little wire into that basket that monitors what they're doing. And then, if they're doing something wrong, pull it back. And so that's kind of the idea. And if you think of a self-service sandbox, like I'm a centralized IT team, I worry, the cat's out of the bag in the sense of these tools, easy to use self-service tools are very all over the place. And maybe it's a Brooklyn, New York business loan officer, or maybe it's a Texas high net worth data science team, or maybe it's a branch marketing, regional branch marketing. And they all have sort of different needs. The New York City guy needs business data and D&B files and Tableau. The data science team needs some data, different set of data, Python access and SQL. And the Seattle people needed a different version. And so the idea of a self-service sandbox is, can you create an environment, a sandbox for your people to play in. And maybe it's a data scientist or someone doing self-service, and sort of monitor and govern what happens. And if they're doing something that you think is wrong, you can then pull it back. But in these environments, how do you then take what they've done if they start to create value? How do you get it into production? How do you provide a path to production? And there's different ideas. In some cases, maybe there's none. Maybe it's just a whole sandbox to try some. There is no path. In other cases, you may, at the bottom, may want to recode what they do. They create some idea, and you're going to put it back in a attribute of a dimension of a fact table in a database, or you're going to run that model centrally for them. Or you're going to find a way to actually run what they've created from a central place. And so we need to think about how your self-service tools can have a path to production so that they can actually successfully do work. Because in the data ops view of the world, whether it's a central team or a decentralized team, there's data and code acting upon that data. And you need to follow data ops principles of version control, of deployment automation, of being able to manage environments and source code control and regression testing, functional testing, monitoring and production, collaboration. All these things that data ops provides are really important to handle. And so the first thing that they're doing is just kind of a request form. Give me a request and monitor it. And there will be no path to production, but they hope to get there. So let me go to the third example, and then I'll be done in the example part. So because we're a half hour in. So a consumer good company had a data scientist team that created a cool model, kind of a sentiment analysis based on what people had written in reviews of products in Amazon and other sites. And taken that, they sort of tried it out. It worked. They tweaked it a bit. They had a Tableau dashboard. And you know what? The product managers in CPG loved it. And so who is going to do this from now to infinity? Who's going to put it into production? And the data scientists don't want to do it. They want to do something new, and that's what they're good at. The IT team has no idea how it works, and don't want this thing thrown at them. And the reality is, it's number one, it's a system, and number two is the data scientists will have to become back involved because models drift. Models are not always perfect, and you need to continually improve them. So the way we thought about it is, number one is that, can you take the code that people have created, the accessing the data, doing the sentiment analysis, putting it in the table, visualizing it in Tableau, and build sort of what we call a recipe, or orchestrate all those tools, and then be able to run those in production. So it tells you that, hey, this is still working, or this is out of compliance. And then set up a way that both the IT team and the data science team can do development, can actually tweak it in some way, shape, or form. And we have this abstraction of their software called a kitchen, or a development environment. And so I think that actually makes a really good scenario, because the centralized IT team may have the inclination, but don't have the time to discover all these requirements and discover what the best algorithm is, what the best way to do sentiment analysis is. And the data scientists are really interested in that. And so organizations need to think about how to find paths to production for the great work that data scientists do, also with regard to the great work that IT teams do. And to say it not as, I've built a house, I'm going to toss it over to IT, but we're going to build a shared deliverable and manage it from now into forever. And maybe the amount of work that the data science team is a lot in the beginning and very little 3 or 6 months later. And maybe the IT team has got some work to put it in a form that can be managed, and then does the monitoring and day-to-day production. But it's a way for these teams to collaborate and have a shared plane of understanding. So let me show what this means in an example, and then I'll kind of get to the conclusion here. So in my experience, it's much better to get something to your business customer sooner that's maybe 70% right, than spend months or weeks building something that you think is perfect, but then learn that it's wrong. And so it's much better to force feedback from your customers earlier and tweak and improve, because you're much less likely to go off for months and then find out ultimately what you did is not correct or not exactly what they wanted. So how can you have multiple takes on what you do? And that idea that if you can get multiple takes, it leads to highlight reels and in sports. So here's an example. So there's a data engineer and a data analyst, and they're working in Tableau for a VP of marketing, and these people work directly for her. And so the VP they have an environment that's in the cloud. It's databases in Redshift. There's Pentaho, which is an open source ETL tool. There's Tableau, which is a visualization tool, and Tableau Online. And we don't particularly care here whether it's Pentaho or Informatica or Airflow or SQL. We don't particularly care how you visualize it, whether it's Tableau or Click or Looker. We really care, can you do this? If your customer says, I want a customer segmentation tomorrow, can you do this as a team? And so why is that? And I think the conditions are, can you give a customer segmentation that is not perfect, that is somewhat imperfect, and get feedback on it from your business customer, and then tweak it until it gets it right. And instead of spending a month or 2 months building something, which is what I did for many years when I have someone do this in my previous role, was to go and I managed data engineers and data analysts, and I would go to the customers and I'd say, features, time, quality, pick 2, not 3. We'll write you a spec and we'll get you something in 6 weeks. And that I thought I was being a great manager. And I often felt like the VPs of marketing and equivalent were kind of rolling their eyes at me after I left, saying, oh, you're too slow. Can't I just get something? And can you give them something in a way that doesn't kill your team with nights and weekends work, in a way that doesn't build technical debt, so that you are unable to manage this in the future, and allows a governed system. And so let me go into exactly how that would work. Well, in this scenario, you need to have a data scientist involved because they're doing the segmentation. And he or she has their favorite tool. Let's say it's a Jupyter Notebook, but it could be R or SAS or an AutoML tool like Data Robot. There's data science platforms. There's just lots of great tools out there. But like a lot of cases, it's not one thing. It's not an island. You need to change the system. So you need to actually add columns into the database to store the batch segmentation. You need to have profitability because that wasn't there in the database, so that's another thing. You need to have a visualization of it. So everyone's kind of got to do their part, the data engineer and the data scientist and the data analyst, in order to do their work. And so that's what's the challenge here. That's why sort of no model's an island, because to do anything, you've got to get a lot of people involved. And now you may say, I'm a data scientist, I can do it all. And perhaps you can. And so I think the challenge is that, do you want to? And do you want to own that for the next years on end? And what happens is, and I have this own experience of kind of this heroism of I can do it all, ends up meaning burnout and meaning that you leave a company. And so it's better to actually try to have a system in which you actually can deliver quickly and in a way that you don't have to do it all yourself. And you can have everyone participate with their own skills. And to do that, really the challenge is that you need a place to develop. And you can't develop in production. And having a place to develop, it means you got to have kind of something that's like your production environment. It's got to have data that is like production. Maybe it's exactly production data, or maybe it's GDPR compliant filtered subset of production data, anonymized data, but it is developed data that's got to be like your production data. And then the hardware and software has got to be like the production, because you don't want to have one version of a Python library in development, another version of the Python library in production, and that's a killer. And so these teams, they need that place to work. And they also need to be able to work in it and prove that what they do works, i.e., I can get the new feature added, but also prove in development that I haven't created regressions, that everything downstream from that model I put in hasn't been broken. And so that's the challenge here, run all your tests. And so the scenario that we typically think about is, how do you make this process of customer requests to delivering value with a team across a distributed set of tools, how do you build a system to make that happen? And how do you invest in that kind of system? Because it's actually the systems thinking, the data ops mode of thinking enables you to do this. And it's not free. and it does take some work to do, and it is worth it. And so that's really the conclusion I like to bring is like, why is all this worth it? So, I think a lot of times heroism is a problem. And a lot of people want to be a hero. Certainly as a technical person, I spent many years in heroism. And the problem is it really means that you're creating some challenges in the future. You're sort of getting ego enjoyment today, setting up a problem for someone else in the future. So don't solve problems, just figure out how to like never have those problems in the first place. And so what does that mean? Well, first of all, there's a lot of talk in the world about ops. There's terms like DevOps or AI ops that you may have heard, DevSecOps. And then I'm talking about data ops, but you also may have heard terms like model ops or ML ops. And what do these all mean? Well, let's just kind of go back to the beginning at the very top. There's a sort of a concept of how you manage an organization, a bunch of people. And that's lean or learning organization or Deming. And it's about a focus on sort of the deployment speed, cycle times, collaboration, measurement, and how you manage people, the organizational management method in software. And I think in generally in data and analytics, there's things like Agile and Kanban and Scrum. There's just a whole bunch of different ways to do it. And in a manufacturing realm, well, that's total quality management, Six Sigma. You look up, Google these things, you'll find hundreds of books on these and hundreds of consultants, because actually managing the change of this is hard and getting the people think. But what the software industry found was that, Agile was created in 2001, and really the idea of DevOps, which is a technical environment that supports iterative, quick development with low errors, came about 8 or 9 years later, because you need a technical environment to manage that organizational method. And so there's lots of variations of it now, GitOps, AI ops, no ops, DevOps, and there's lots of ways. And in my mind, the people who derive value from data scientists, data engineers, analysts, governance, all those people I talked about in the beginning, they do have ops things that they have to do. Similarly, they need a technical environment to do this. And we call that data ops, but there is aspects of it that apply specifically to their role, data GovOps, model ops. And so the way I sort of think of it is that your functional area may have some ops related to it. Like if you're a data scientist, you may be more interested in you may think that I've just got to do model ops. Or if you're in data governance, you just have to do data GovOps, or you've got to do self-service ops. And these terms are a little bit funny, and they're not, some of them aren't widely accepted and some of them are. But in general, there is an ops area, a way to automate these functions so that you can iterate quickly with high quality. And so the way that we think of it is that, in our view of the world, is that every team, data governance, engineering, science, self-service, are all sort of part of, on the left-hand side, they've got these functional roles, and they're trying in the end to deliver value to a business customer. But in the other way, that you need, in some ways, a platform that can handle all these roles and all these types of systems, whether it's model ops or data engineering ops or data GovOps. And so we think that thinking of it from a systems-wide, not an island specific, but the whole ocean, I guess, is a better way to do it. Sorry for mixing the metaphor. And so how do I start with this? And since we're getting near the end, so there's I can tell the story of how I started. And so back in 2005, we were having a lot of problems. Models were getting out of line, the data was wrong, the visualization was wrong. I was getting calls from customers saying things are broke. And I was sort of dreading going into Google work, because like, oh, was it my data engineer's fault? The person who wrote the visualization role, did the data scientist screw up? And like, it just was a painful life. And so I started to read Deming and said, okay, let's form what's called a quality circle. Let's just, every time we have any problem, no matter how significant, let's write it down, put it in an Excel sheet. And then every 3 or 4 weeks, let's just meet and look at the problems and see if there's something in common across these problems, and just find one thing across all those problems that we can automate a way that we can really fix. And maybe it was as simple as a check script, or maybe it was as simple as having someone manually check something before it goes to the next step, but let's fix it. And what we did is take away the shame and blame around errors, and instead try to say, well, errors are opportunities for improvement. And so anybody can do that. You don't even need Excel. There's lots of tools like Excel, Google Docs, whatever. You just need to count and categorize your errors and think about how you can fix them, and you'll see some improvement. And then the second part is decreasing the cycle time of change. I think most people who do data and analytics don't spend enough time creating automated tests, not just unit tests, but system tests, end-to-end tests, regression tests that tell if your system runs in production that it's going to work, or if in development something's wrong. So create some automated tests. And then on collaboration, think of everything you do as a system. So put your ETL, your Python code, your model code, your viz code, your parameters all in Git. It's free. Store it, give it in one place, so everyone can see it. And at least there's there, it's version controlled, it's backup, and you can start using Git immediately. And then another part is just I think it's important to measure your process. So why not every week count your errors? Count how fast you deploy. See what percentage of your code's in Git, and just track it as metrics. And you'd be surprised how much you can, by thinking about these things, how much you can start make a change and a difference. And so we think that's a good first step about focusing on these items. But we're also a software company, and we've got some software to sell. And so here's the last slide, which is our sales slide. But before I get to the sales slide, there's one more thing I want to talk about on how to start today. So rethink the percentage effort that your team does, because everyone today is focused on tools and technology and data, maybe 97%, maybe it's 95%. Very little is focused on the people and the process and the operations. It's kind of seen as for lesser beings. Oh, we do it in part-time, we do it manually. And what's happened, and this is pretty much the way I thought of, I was a software engineering manager in 1999. This is pretty much the way I thought of the world. We had sort of a release guy. He played the mandolin at parties. He wasn't paid as much as everyone else in our SaaS product. And this is what I thought you had to do. And so I think what the software world has learned is that DevOps and investing in DevOps or investing in operations is actually a really important part. And most good software teams devote a third, 40% of their team on this operational stuff. And I think we should just start to say, okay, maybe it's not 40%, let's say 20% of your effort to focus on processes, automation, testing, deployment, environments. And what you'll find is you'll be able to get more done faster and better and happier because you've invested in this. And that investment will mean then you'll actually get more work done. And so it's a really counterintuitive idea. And what we do see is that these levers, by focusing on cycle time, sort of pushing up the graphic equalizer, focusing on error rates and collaboration and measurement, you can kind of push the graphic equalizer together. And the best in class companies do all these things well. And it's not a trade-off between one or the other. And when you do all these well, you can see costs and productivity. Costs go down and unhappy customers go down. So think of it in that graphic equalizer way. If you push on those things, you get a better result by focusing on the system and not just the tools and technology. And so as I stated before, we've written a lot about data ops. So we wrote a book that's free that you can get. We wrote a manifesto that you can go sign that talks all about these ideas. We sort of tried to open source our vision of what data ops is. And in order to fund that, we have a software product that we provide, and it helps you accelerate your journey to data ops in an enterprise. And so we've had a lot of success helping customers, go from no data ops to full data ops in whatever role in their company: data science, data engineering, data operations. And so that's it from my presentation. I hope you enjoyed it, and I don't see any questions yet. If you've got a few questions, we can feel I can answer them. So I think that's it. We had set an hour. We've got it's at 47 minutes, so I finished a bit early. I hope this was useful for you. And oh, someone raised their hand. Happy to answer a question. So I think that's it. If there is no questions, I am going to say that we're done. So thank you much. I appreciate your time. And again, if you have looking for just more relevant information on this today, you can go get our book or our manifesto or just Google DataOps and you'll learn